Hello everyone, my name is Nirja Joshi and today I'll be presenting my midterm evaluation on web development. Throughout this course, we have learned many different technologies including HTML, CSS, Bootstrap, JavaScript, Node.js, Express and MongoDB. At first, these may seem like complete separate topics, but they are actually different pieces of one complete system. Rather than explaining each technology independently, today I'll answer one central question. How does a single click on a web page become information displayed on the screen? By following one request from the browser all the way to the database and back, we'll see how every technology we have studied works together to build modern web application. So before we begin, let's first look at the objectives of the today's presentation. These are the goals I hope to achieve by the end of this presentation. First, I want everyone to understand the purpose of each technology we have learnt in this course. Instead of memorizing HTML, CSS, JavaScript, or Express individually, we should understand why each one exists. Second, we'll see how the front end and the back end communicate with each other using HTTP requests and APIs. Third, we'll trace the complete life cycle of a web request, starting from the moment a user clicks a button until the data is displayed on the screen. Then, I'll demonstrate how to build a simple Express API during a live coding session. Finally, I'll conclude with a creative analogy that summarizes why all of these technologies are equally important in building modern web applications. So let's begin with the big picture. Before discussing individual technologies, I would like to start with the complete picture. One challenge many students face while learning web development is treating every technology as an isolated topic. We learn HTML one week, CSS the next week, JavaScript after that, then Node.js, Express, and finally MongoDB. It almost feels like six different courses. But in reality, every one of these technologies is a part of the same journey. To understand that journey, let's imagine a very simple example. Suppose we have a student portal web page and there is a button labeled Load Students. The user clicks that button, and from the user's perspective, it feels like one simple action. But behind the scenes, many things happen in just a few milliseconds. The first comes the browser. The user clicks the Load Students in Chrome. The second is the front end. HTML is responsible for creating the structure of the page. Then CSS styles those HTML elements. Then comes the interesting part, the JavaScript. JavaScript then prepares an HTTP request using the Fetch API. Then comes that the request travels over HTTP to our backend server. HTTP stands for Hypertext Transfer Protocol. Then the request reaches our server and the Node.js is running on that server. In real application, Express retrieves the information from MongoDB. MongoDB stores our application's data permanently. Once MongoDB returns the requested data, Express converts it into JSON. JSON stands for JavaScript Object Notation. Finally, the JSON's response reaches the browser. JavaScript reads the data and updates the document object model, that is the DOM. So, although the user experiences one single click, that request has actually traveled through the browser, JavaScript, HTTP, Node.js, Express, MongoDB, and back through the Express, and finally back to JavaScript, which updates the web page. This single journey connects every major technology we have learned during this. Now let's begin exploring each technology, starting with the foundation of every website, the HTML. HTML stands for Hypertext Markup Language, and it is the foundation of every web page on the internet. HTML is responsible for defining the structure and content of a web page. It answers a very simple question: what should exist on the web page? Should there be a heading, a paragraph, a button, a form, an image? HTML defines all of those elements. Before decorating or painting a house, we first need walls, doors, and rooms. Similarly, before styling a web page, we first need the content itself. During this course, we learned many HTML elements, which includes the headings, paragraphs, forms, links, buttons, tables, and lists. Each element has a specific purpose and helps organize information meaningfully. We also learned about the semantic HTML. So instead of using the generic division element for everything, semantic tags such as header, nav, main, section, footer clearly describe the role of each part of the page. These provides several important benefits such as accessibility, search engine optimization, and maintainability. Finally, when the browser reads our HTML document, it creates something called the Document Object Model or the DOM. This DOM becomes that object the JavaScript interacts with later in the application. Now that we have built the structure of web page using HTML, the next question is, how do we make it look attractive? That's where the CSS comes in. CSS stands for Cascading Style Sheets, and its purpose is to control the presentation of the HTML elements. If HTML is the blueprint of a house, CSS is the paint, furniture, lighting, and decoration that makes the house visually appealing. One of the first concepts we learned in CSS was the selectors. Selectors tell the browser which HTML elements should receive a particular style. During this course, we worked with several types of selectors: element selectors, class selectors, and ID selectors. We also briefly explored descendant selectors, child selectors, attribute selectors, and pseudo classes like hover, which allow us to style elements based on user interaction. Another very important concept was the CSS box model. Every HTML element is treated as a rectangular box consisting of four layers: content, padding, border, and margin. We also learned different ways to arrange elements on a web page. First was flag box, that is for one dimensional, and the other was CSS grid, that is responsible for two dimensional. Finally, we learned about responsive web design using media queries. After that comes the Bootstrap. Bootstrap is an open source CSS framework that helps developer build responsive and professional looking websites much faster. Instead of writing every style manually, Bootstrap provides a large collection of pre-built components and utility classes. During this course, we learned several key Bootstrap concepts. The first was Bootstrap grid system. The grid divides the page into 12 responsive columns, making it easier to create layouts that automatically adjust for desktops, tablets, and mobile devices. Another important feature is Bootstrap components. Instead of designing buttons, cards, navigation bars, alerts, and forms from scratch, Bootstrap already provides professionally designed versions that can be customized as needed. The next comes the JavaScript. JavaScript is the programming language that brings web pages to life. HTML defines what appears on the page, CSS defines how it looks, JavaScript defines how it behaves. During this course, we learned many core JavaScript concepts. We started with variables using let and cons to store the data. We learned different data types such as strings, numbers, booleans, arrays, and objects. We learned different functions which allow us to organize reusable pieces of code instead of repeating the same logic multiple times. One of the most important concepts was the document object model or the DOM. When a web page loads, the browser converts the HTML into a tree like structure called the DOM. JavaScript can interact with this DOM by selecting elements and change them dynamically. We use methods such as getElementById, query selector all. Once we select an element, we could modify the text content, styles, attributes, classes, or even create entirely new HTML elements. Another important topic was events. Instead of constantly checking whether something has happened, JavaScript simply waits for events such as clicks, keyboard input, mouse movement, or page loading. When the event occurs, JavaScript executes the corresponding function. This is called event driven programming. Then comes the modern JavaScript ES6, also known as ECMAScript 2015, introduced many improvements that have become standard in modern JavaScript development. So, up to this point, everything we discussed runs inside the browser. But modern applications also required server side programming. That's where Node.js comes in. Before Node.js was introduced, JavaScript could only run inside web browsers. If we wanted backend development, we needed completely different programming languages such as Java, PHP, or Python. Node.js changed that. Node.js is a JavaScript runtime built on Google's V8 JavaScript engine. It allows the JavaScript to execute outside the browser, enabling developers to build servers, APIs, and backend applications using the same language they already use for front-end development. During this course, we also learned about the NPM, that is the Node Package Manager. NPM give developers access to thousands of reusable libraries. We also learned about the packet.json file. This file stores important project information, including the project's name, version, scripts, and dependencies. Now that JavaScript can run on the server, the next question is how do we actually build a web server that receives requests and send responses? That's exactly what Express helps us to do. To this point, we have been working almost entirely in the browser, but eventually our application needs information that does not already exist inside the browser. For example, imagine our student portal needs to display a list of enrolled students. That information is not stored inside the HTML page. It needs to come from a server. So that's where exactly Express.js comes in. Express is a lightweight web framework built on the top of Node.js. During this course, one of the first things we learned was how to create a simple Express application. We start by importing Express, then we create an Express application object. Finally, we tell the application to listen on a particular port, such as 3000. Once the server starts running, it waits for incoming requests from client like web browsers. Another important concept we learned is routing. A route simply tells Express if someone requests this URL, execute this function. This means that whenever a browser gets a GET request, Express will execute the associated callback function. So Express knows how to receive requests, but Where does the actual student information come from? That's where the database is becoming essential. Every modern web application needs somewhere to permanently store its information. If we stored our student list inside a JavaScript array, the data would disappear every time the server restarted. That's why we use databases. During this course, we learned MongoDB, which is NoSQL document database. Unlike the traditional relational databases that organizes data into columns and rows, MongoDB stores information such as documents inside collections. These documents look very similar to JSON objects. For example, one student document might contain the student ID, name, major, and email. Another advantage of MongoDB is its flexibility. The other advantages are it is highly scalable, popular in modern apps, easily JavaScript integration is possible. During the course, we also learned how Node.js communicates with MongoDB using the MongoDB driver. Express sends a query to MongoDB, then MongoDB searches the requested collection, the matching documents are returned back to Express. And finally, Express converts those documents into JSON and then sends back them to the browser. These diagram represents everything we have learned in this course. Let us imagine that user clicks the load students button. What exactly happens? So the first step is the browser detects the button click. Once the click occurs, JavaScript executes the load students function. Inside that function we call the fetch students query. At this moment, the browser creates an HTTP GET request. This request contains several pieces of information: HTTP method, URL, request headers, and other metadata. The request then travels across the network until it reaches our Express server. Express continuously listens for incoming requests. When the request arrives, Express compares the requested URL against all the registered routes. Since we created app.get, Express finds a match. The callback function executes. Inside that callback, Express retrieves the student information. During today's live coding demonstration, we'll simply return an array. In real application, Express would instead query the MongoDB. MongoDB searches the student's collection and returns the matching documents. JSON is ideal because it is lightweight, human readable, and JavaScript can process it immediately. The response travels back across the network to the browser. JavaScript waits for the response using the await fetch. Once the response arrives, response.json converts the JSON into JavaScript objects. Finally, JavaScript loops through each student, creates new HTML elements, inserts them into DOM, and the browser immediately updates the web page. Notice something important. The web page never refreshed. Only one small portion of the page changed. This is exactly how modern applications like Gmail, Facebook, Netflix, and LinkedIn update their content dynamically. On the left side of the slide, we have our front end JavaScript. This code is responsible for requesting information from the server. The Fetch API provides modern, promise-based way of making HTTP requests. During this course, we primarily used GET requests to retrieve the data. First, we call the fetch students. This returns a promise because network communication takes time. Instead of blocking the browser, JavaScript continues running while waiting for the response. That's why we use async and await. The keyword await poses only that function, not the entire web page. Once the response arrives, response.json converts the JSON into JavaScript objects. We then iterate through the array, create list items, and display the information on the web page. These demonstrates one of the most important ideas in modern web development. The front end and back end remained separate, but they communicate continuously through APIs. This is a simplified version of the Express application that we will build during the live demonstration. The first line imports the Express library, then we create an application object. We define an array containing a few student records. Next, we register a get route, that is app.getStudents. Whenever a browser requests /students, Express executes this function. And inside the function, res.json students automatically converts the JavaScript array into JSON and sends it back to the browser. Finally, app.listen 3000 starts the server and begins listening for incoming requests. The only difference in a production application is that instead of running a hard coded array, Express would retrieve the data from MongoDB. So far, we have discussed the concepts and architecture. The best way to reinforce these ideas is to implement them ourselves. In the next few minutes, I will build a small Express application that exposes a /students endpoint and connect it to simple front end using the Fetch API. As we build it, notice how every technology we have discussed today plays a specific role in the application. We build a simple Express server that exposes a student's endpoint and connect it to a front-end page using the Fetch API. Also, this example is small, but it contains almost every concept we have learned in this course. I have separated the project into different files. HTML defines the structure, CSS handles the presentation, JavaScript manages the interactivity, and Express provides the backend API. This separation of concerns makes projects much easier to maintain. So first of all, I created this folder students API. Then inside the terminal, we have to type npm init.y. This creates package.json file. Afterwards, I wrote the index.html file. This file references the style.css and the script.js. The style.css file has the CSS for the application, and the script.js, the async function, loads the student data from the server. Then this line gets the student list from the backend, then converts the response into JavaScript objects, gets the list where we'll show the students. This line clears the old list before adding new data. With the help of these line, we go through each student, create a new list item, show the student's name and major, and adds to the list. In the end, we'll write the app.js file. Define the port. So the first thing we do is import the Express library. Since Express isn't built into Node.js, we installed it using npm. Now this line creates our Express application. Every web service listens on specific port. I'll use port 3000, which is commonly used during development. This middleware tells Express to serve all static front-end files such as HTML, CSS, and JavaScript automatically. This creates the API then. And finally, we start the server and begin listening for incoming requests. I would like to conclude with one creative analogy that helped me understand why all these technologies are important. I like to think of a web application as an orchestra. HTML is like the sheet music. It defines what should exist, just as sheet music defines what notes should be played. CSS is like the musicians. The notes already exist, but the musicians determine how beautiful the performance becomes. Bootstrap is like having experienced musicians who already know many common arrangements. So instead of creating everything from scratch, we can use proven components and customize them when needed. JavaScript is the conductor. The conductor does not play every instrument. Instead, the conductor coordinates the timing, communication, interaction between every section. Then comes the Express. Express is the stage manager working behind the scenes. The audience rarely notices the stage manager, yet nothing would happen without them. MongoDB is the music library. Every musical score is stored there until it's needed. Similarly, MongoDB stores all of our application's information. The browser is the concert hall where the performance actually takes place. And the user, finally, the audience represents the user. The audience does not think about the music sheet, conductors, or the stage managers. They simply enjoy the performance. Likewise, users don't think about HTML, Express, or MongoDB. They simply expect the application to work. No single instrument creates a symphony. No single technology creates a web application. Every technology has specific responsibility, and together they produce one seamless experience. I hope this presentation has shown not only what we learned through the course, but also how these concepts fit together as one complete system. Thank you very much for your time. I would be happy to answer any questions. Thank you so much once again. Thanks for watching.